Hi, my name is LUYING GONG. This is my presentation for IFMG 614 final project. As we know, in recent years, in order to achieve sustainability and set a successful BPR, more and more organizations are on the way to find efficient MIS methods to enhance their sustainable development. And in this study, I will do research on several kinds of MIS methods and find out how can they improve American manufacturers' BPR and sustainability. All over the world are now pursuing sustainability. The following graph was made in 2012 and illustrated that till 2012, Europe seems as a sustainability leader in the whole world, which have achieved about 63% sustainability, and North America ranked at second, achieved about 35% sustainability, which reached 55% of Europe. There is a little bit long distance from North America to Europe, and North America need to pay attention to increase its speed to achieve sustainability. An efficient business internal system is an essential BPR enabler. A successful BPR will reduce the cost or cycle time, improve the quality potentially, and also act as an important role when business on the way to pursue sustainability. MIS refers to computer-based system. It provides people a tool to organize, evaluate, and manage their department efficiently. People can use MIS to see past, evaluate present, and predict future. Also, MIS can help people to analyze the information, check operations of each business unit or function. MIS help managers to make their tasks easier, redesign their organization, change the way they work, and achieve spectacular improvements. It provides an efficient platform for them to make design, improve energy efficiency, and reduce energy wasting. Thus, we can see MIS can be widely used in current world and it will contribute to BPR and sustainability. Barry in 2013 proposed to use artificial neural networks backpropagation algorithm to estimate carbon dioxide. He regards global oil, natural gas, coal, and primary energy consumption as four input layers of the model, and the hidden layer function is nonlinear and consists of 5 neurons. Next, he utilized the output layer as a linear activation function, which consists of 1 neuron, and corresponds to carbon emission estimation. Finally, he developed artificial neural networks model as left graph. Then he found out the difference between actual value and the estimated value to indicate the accuracy of the model he proposed. From the graph on the right, we can find out that there is a small difference between actual and estimation, which proves that the model is able to produce a very accurate estimation results about carbon dioxide. Several researchers have worked to develop artificial neural networks backpropagation model to predict expenditure of carbon dioxide based on the fuel used for boiler machines operation in sugar industry. The researchers found there were three main fuels affected carbon dioxide: biogas, firewood, and MFO. The researchers regarded these three fuels as input variables. Then carbon dioxide emission will be computed by fuel consumed. Thus, the input and output relationship is shown as here. Next, the authors used 125 datasets from 2009 to 2013, including biogas, firewood, and MFO to calculate carbon dioxide emission, followed by 2006 IPCC guidelines, and got following optimal architecture of artificial neural networks model. From above table that researchers got in their study, we can find out that RMSE is 0.055, which almost to zero. That means the model that proposed have high accuracy of prediction. And the researchers also drawn a diagram to show the difference between actual value and their prediction value, which also demonstrated that the proposed model performed excellent for the prediction of carbon dioxide emission. In addition to artificial neural networks, I also did some researches on physiology. In that research, there are about 65% potential energy of fuel loss in the engine. The internal combustion engine lost their 42% of energy to exhaust it and 28% of energy to the cooling system. So to equip a system to recover the energy, reduce fuel consumption are necessary for American manufacturing sustainability. In 2013, some researchers attempted to apply physiologic approach into waste energy harvest system to reduce energy wasting and improve engine efficiency. Researchers regarded engine coolant and mass flow rate of supercharged air as input parameters, the outlet port temperature of system as output parameter, then assumed the maximal temperature of boiling for fuel is 120 Celsius. Then they designed physiologic system to control the output temperature of the system. Finally, they got output temperature as following graph, which helped them to find out the mass outlet temperature will be less than 110 Celsius. From their research, we find out that apply the physiological method into waste energy harvesting system will improve the efficiency of system and support the sustainability. ERP is business management software, which can be used to help manufacturers to collect, manage, and interpret data from business activities. And it is a useful tool for manufacturers to make estimation. For example, Microsoft Dynamic GP can help companies to get to know their suppliers and inventory need, keep the real-time inventory level, and make a reliable forecast for reordering, which help companies to deliver correct product to customer at the correct time. Thus, efficient improve the supply chain and reduce the risk. The SAP ERP approach is also a type of ERP, which help companies to improve supply chain and evaluate the risk, helping companies to make design for production planning. ALOWA approach aims to preserve the best quality of free enterprise and market-driven regulation while addressing systemic weaknesses inherent to capitalism. Roger in 2014 have used this approach to evaluate risk in supply chain. ERP system provides a tool for business to create a report and forecast the future, and the ILOWA approach helps people to use risk probability impact metrics to determine the optimal solution. We can utilize the ERP system and the IIoWA approach together to enhance supply chain management and improve sustainability. In the research paper, Quantitative Risk Level Estimation of Business Process Reengineering Efforts, the authors aimed to find the risk to evaluate business process design. In the process to assess risk, the authors utilized the regression model to find out scores in membership value, then used regression model to show the relationship between organizations' critical factor points and the scaled business process redesign scores as following graph. They also developed the tool that uses triangular fuzzy numbers to find out the degree of success or failure of proposed business process redesign efforts. After the research, they got a diagram about BPR scores and critical factor points. Then substitute the total critical factor points into the regression model and find out the triangular fuzzy number. Fuzzy logic not only can be used to evaluate risk, but also can be used to measure performance. The George and Mitchell in 1998 have already proposed that fuzzy cognitive maps can be used to support business process redesign planning. In the research, they used the fuzzy cognitive maps method to measure the business process redesign project performance. The fuzzy cognitive maps contain business metrics and associated decision variables. It provides a tool for organizations to assess their relationships and examine different scenarios. And fully cognitive maps have been extended to support decision making. Thus, fully cognitive maps are good tools that can be used to improve business process redesign project. After all analyzed, we can find out that all proposed methods could be used to improve American manufacturing's BPR and sustainability efficiently. In order to adapt to sustainability trends, all manufacturers in America need to pay attention to take measures to support their sustainable development. We now are stepping into the era of big data, and we should recognize how important the role of MI is in the sustainability improvement. Also, for an organization development, design a successful BPR will increase their competitiveness, optimize the process, and improve sustainability. Since the world is always changing, there are many uncertain factors that will influence Americans' manufacturing sustainability. And because fuzzy logic is a very efficient method that people can use to solve uncertain questions, people need to develop fuzzy logic in their system to enhance their sustainable development. Also, people need to develop other potential MIS methods to support sustainability. For BPR, MIS methods are also an enabler. MIS is the most popular and efficient high-technology approach that can be used in economic, society, and the environment. And we cannot stop to develop more efficient methods to improve economy and enhance sustainability. Above are all of my presentation, and thank you for listening.